A cuttlefish will stare at a dead shrimp for 2 full minutes and refuse to eat it. Not because it isn't hungry, because it has learned that if it waits, a live one arrives. In a lab tank, cuttlefish held out for up to 130 seconds for the better meal. And that is an animal with no spine, no cortex, and a life that lasts about 2 years. Most 4-year-old children fail that same test. But the strangest part isn't the waiting. It's what the waiting turned out to be for. Hold on to that. The experiment came from Alexandra Schnell at the University of Cambridge, working at the Marine Biological Laboratory in Woods Hole, published in 2021. She built a version of the famous marshmallow test for cuttlefish. 2 clear chambers. One held a piece of raw king prawn, available instantly. The other held a live grass shrimp, the food they actually prefer, behind a door that opened only after a delay. Symbols on each door told the animal which was which. The cuttlefish learned the symbols. Then they started refusing the easy meal. They didn't just sit there passively. Several of them turned their bodies away from the immediate food, like a child covering their eyes. When the researchers made the live shrimp unreachable instead of delayed, the cuttlefish stopped waiting and took the prawn straight away. So this wasn't stubbornness. It was a calculation, updated in real time. Then came the part that should bother you. The cuttlefish that waited the longest were also the fastest learners. In a separate task, where the animals had to figure out which visual cue meant food, and then unlearn it when the rule flipped, the best waiters were the quickest to adapt. The same link shows up in humans and in chimpanzees. Patience and learning speed appear to be the same underlying machinery, wearing 2 different faces. But why would a mollusk need patience at all? Here's the answer, and it reframes everything. A cuttlefish spends most of its life invisible. It hides, it matches the seafloor, it waits in plain sight while barely existing. Every moment it moves, it becomes findable. Predators are watching from above and below. So for a cuttlefish, breaking cover to grab mediocre food is not just a bad meal. It is exposure. Waiting isn't a virtue it developed. It is the only affordable way to be alive. Its self-control is a byproduct of hiding. Now think about the human version. The original marshmallow experiments, run by Walter Mischel at Stanford in the 1960s and 70s, seemed to show that the kids who could wait for a second treat grew into more successful adults. That result became a whole industry. Willpower as destiny, discipline as character, except it didn't hold up cleanly. A 2018 replication led by Tyler Watts found the predictive power shrank dramatically once you accounted for the child's family background and environment. And in 2013, Celeste Kidd ran a version of the test where children first experienced an adult who either kept a promise or broke one. The kids who had just been lied to waited barely a fraction as long. They weren't weaker. They had simply gathered evidence. That's the loop closing. The cuttlefish and the child are running the same computation. Not how strong am I, but is the second shrimp actually coming? Which means self-control was never really a muscle. It's a forecast. Your brain is constantly estimating how reliable your environment is, and then spending or withholding patience based on that estimate. If you grew up somewhere the promised thing often didn't arrive, grabbing the immediate reward was not a failure of discipline. It was accurate. If this is the kind of thing you want more of, subscribe, and you'll get one of these a week. So the next time you can't wait, notice what you're actually doing. You're not losing a fight with yourself. You're reporting a result. Somewhere in your history, the door opened and nothing was behind it, and your body wrote that down. A cuttlefish will stare at a dead shrimp for 2 full minutes. Not because it is disciplined, because the ocean has never once lied to it about the second shrimp.